Welcome everyone to this video. We are going to discuss question number 4 uh, in JEE 2023 Physics Paper 1. Okay, so basically we have a bar. That bar is has a mass of 1 kg. So it is pivoted uh, at one end and it is kept in a horizontal plane. So the surface on which it is kept is smooth, so it can rotate freely. So we have the bar length given as some length L. Okay, we can take the length of the bar as L, and there is a mass small m whose mass is 1/10 the mass of the bar, m by 10. It is going to strike the bar right in the middle and it's going to turn back on its path after striking it. Question is, what is the speed of the mass m when it turns back, and what is the angular speed of the bar as it is uh, starts turning? So omega of the bar that we need to evaluate. So the question is pertaining to the chapter of rotational mechanics. So we need to use conservation of angular momentum. That much is clear. That the angular momentum of the system, that is the bar and the mass, is conserved about this point O. In addition to that, we also need to think about collisions. So we need to form one equation of uh, coefficient of restitution. That is relative velocity of approach of the masses is equal to relative velocity of separation of the masses. So how do we do that? So we'll say omega L by 2. This would be the speed of the point on the bar with which it is uh, going away from the mass m. Mass m also itself is going away with the speed v, and let's say it is approaching the system with the speed v naught. So since the collision is elastic, this equation we can write. Had it been in an inelastic collision, we will multiply it by e. Okay. So now let us proceed with our uh, equation. So we have conservation of angular momentum. We will say the angular momentum of the approaching mass about point O is mv naught L by 2. This will be equal to the angular momentum of the bar, that is ml square by 3, and this would be actually 10m because the mass of the bar is 10 times that of the mass m, and then minus mv L by 2. So this is the equation which is relevant for us. So, and we have to multiply omega as well. This is the omega which we are multiplying. So we have um, v naught by 2. So this is 10 by 3 L omega minus, uh, since we have cancelled out one L, and then the other L is also getting cancelled out, so this is V by 2, right? So from in these two equations we have to get rid of the velocity, so that is pretty easy. We can say this is V naught is equal to 20 by 3 L omega minus V is equal to omega L by 2 plus V is equal to V naught. So adding these two equations, 2 V naught is equal to um, L omega 20 by 3 plus half, that is 43. So value this would be 43 by 6. So the value of V naught is what we know. V naught is equal to 5. So this implies 10 is equal to L omega into 43 by 6. So after solving this, you will get omega as some uh, 6.98, very close to 7 radians per second. Then how will you find velocity? So velocity you can find using any of the equations. You can say velocity I can find using this equation. The velocity is equal to V naught minus omega L by 2. So V is equal to, what is the velocity V naught? The V naught is 5. We can put the value of omega as some 7. Some 7 approximately. L is 0.2. So this will become 0.1. So this value is coming out to be 4.3 meters per second. So option A is correct.